Alright guys, today we're going to work in lesson 2.2 out of your textbook. If you want to pause the video for a minute and go locate lesson 2.2, that way you can follow along. So today we're going to learn to write and solve equations. Alright, so solving an equation in one variable algebraically involves isolating the variable by applying properties and simplifying. Besides using an algebraic approach, you can use a table or a graph to solve an equation, as shown below for the equation 2 times x plus 8 minus 9 equals 6x plus 1. Alright, so one thing I want to point out when it says isolating the variable, make sure you know that we're going to isolate the variable. That means we get the variable on one side of the equation by itself. Okay? Alright, so let's look at the equation that they have given us. Alright, so it says solve the given equation for x. So when you see an equation, the first thing you want to do is get rid of the parentheses. So to get rid of the parentheses, you have to do distributive property. So distributive property tells us that we're going to multiply the 2 by both terms inside the parentheses. So 2 times x is 2x. And 2 times 8 is 16. So we need to come down below and find the one that says 2x plus 16. Everything else in the equation will stay the same for now. So all we wanted to do was use the distributive property. Alright, so the next thing it says is to combine like terms or combine constraints. Alright, so 16 minus 9, you can see neither one of those have a variable. And they've done 16 minus 9 is 7. So everything else here stayed the same, but they just combined like terms, which in this case they're calling constraints. All right, then from here, what are we going to do to go from here? So we need to get the variable on one side. So we need to isolate the variable. So you're going to subtract 2x from both sides. If I do that, that leaves me 7. 6 minus 2 is 4. So we're going to pull up this equation here. All right. Now it says subtraction property. So we're going to subtract 1 from both sides. Again, we're trying to isolate, or we're trying to get the x by itself. So if we subtract 1 from both sides, that is subtraction property as well. So they've already got the equation there. We just have to drop in what it is. All right, and then the next thing we're going to do is divide both sides by 4, because we're still trying to get that x by itself, and that leaves us 1.5 equals x. And then you can hit and check it, and it will tell you if you got them correct. It also goes through a little explanation here, so if you want to go back and check like what the properties are, the different properties are in your textbook, and that's a good thing to review. All right, the next thing says evaluate each expression in the equation using integer values of x. So you can see that we have a table, and they've assigned integer values of x. So we're just going to take the x's that have been assigned, and we're going to evaluate for these two equations. Or two expressions. These are expressions, they don't have an equal sign. All right, so if you take negative 3, and I may go a little faster than you can go, but if you take negative 3 plus 8, that gives you 5, times 2 is 10, minus 9 is 1. So they've already evaluated these for these values of x. So over here, if I do 6 times negative 3, again, this is my x value. So 6 times negative 3 is negative 18, plus 1 is negative 17. And then they go down to negative 2. Negative 2 plus 8 is 6, times 2 is 12. 12 minus 9 is 3. All right, so this is good practice on mental math. All right, so you can check to see that each of these x values, when substituted into these expressions, are going to give you these values here. All right, it says the values of the two expressions are almost equal when x equals 1 and when x equals 2. So if you come over here and look, when x is 1, this one's 9 and this one's 7. And then at 2, it's 11 and 13. So those are getting close to being equal, but they're not exactly equal. All right. Now it says use the table, evaluate the expression on each side of the equation using values of x between 1 and 2. All right, so we're taking these same two equations, but since we know that somewhere between 1 and 2, these are getting very close, we're going to evaluate just the numbers between 1 and 2. So you can see they've chose 1.1, 1.2, 0.3, 0.4, and 0.5. So all we have to do to evaluate these is plug them in. So just simply do 1.2 times 6. You may want to take your calculator since the decimals are a little bit harder. But the first one, if I do 6 times 1.2 plus 1, I'm going to get 8.2. Alright, so I want you to pause the video for a second. Go ahead and solve these or plug these in your calculator yourself and figure out what numbers go in these drop boxes, and then start the video again. Alright, hopefully you've had time to get these done. So I got 9.6. I got 9.4. And I got 10. So hopefully you guys got the same thing when you plug those values in. Again, here below, it's going to show you that these numbers, when substituted in the expression, how you can simplify those. All right, now if we look at this, we were trying to see when they got close. So these values seem to be getting closer and closer. When we substitute 1.5 into this expression, we get 10. And when we substitute 1.5 into this expression, we get 10. So we know that when we substitute 1.5, we're going to get the same y value, or the same thing when we evaluate it. All right, it says, so when are the values of the expressions on each side of the equation equal? The expressions are equal when, we already looked at this, when it says x was 1.5. So we're going to type in 1.5 and check it. All right, now it says use the graph. So this is another way to find where the two equations or expressions in this case are equal. So it says set the expression in the equation equal to y equals. To obtain two equations, graph the equations using the graphing calculator. So you can see, I don't know if this is TI-84 calculator or the Desmos version, but you can see they've got a screenshot here of a calculator. So let's blow this up a little bit so you can see it a little bit better. And when you look, this is your x's and this is your y values. And if you come over to 1 and you go up, you can see it doesn't cross there, but it does cross at 1.5, which is what we found. So you can see that the intersection of these two equations is 1.5. So what we did was just put the first expression in y1 and put the second expression in y2, and then it will graph these for you and you can see the intersection. So that's going to be a way to see the solution as well. All right, so it says the line appears to intersect at 1.5 and 10. So the solution is what we found out before, which is 1.5. So graphing is another way to find the solution. So above we found it using the table, and now we have done it using the graph. All right, it says you can write and solve an equation to solve a problem like the following. Eduardo is looking for employment in sales and is considering 2 job offers. Job A pays a base monthly salary of $3,000 plus 10% commission on sales over $5,000. Job B pays a base salary of $2,500 plus 15% commission on sales over $6,000. What dollar amount of sales would Eduardo have to make in a month for the two jobs to pay the same amount? What would his pay be for the month? All right, so using this information, we're going to say let S equal the dollar amount of sales that Eduardo makes in a month. Complete the verbal model. All right, it says job A's base salary. Okay, we can go up here. We can see that job A's base salary is $3,000. So that's what they have listed here. It says job A's commission would be 10% on things over $5,000. So commission over $5,000. So job B, we want this to be equal to this because we want to see when they make the same amount. So the base salary, you can see, is $2,500. And then 15% over $6,000. So we need the expression that represents 15% of sales over $6,000. Now remember, 15% written as a decimal is 0.15. So that's why we have the 1.5. And then that's sales minus the $6,000 to represent the commission. All right, now it says write an equation, state the verbal model as an equation. So it's got the 3,000 plus the 10% times sales minus the 5,000 equals 2,500. So this is the second one. This is the one we just looked at. 15% times sales minus the $6,000 commission. All right, so all we're having to do is fill in the missing pieces. All right, now it says solve the equation and justify the solutions. All right, this one's a little bit hard to see. I'm going to have to change the zoom a little bit so that we can see the whole question here. Let's see. All right, makes it a little bit harder to read, but we'll zoom it back out when we finish this. All right, so the given equation, that's the first equation. That's the one from above that we just looked at. For some reason, it's not letting me drop here. Let's see. All right, then you want to double check and make sure. So we've got the 3,000 plus 10% times S minus 5,000. That's what we have on the left. And we're going to set that equal to 2,500 plus 15% times S minus 6,000. So that's our given equation. That's what we're starting with. And then, let's see if I can blow this back up just a little bit. All right, so then it says, what are we doing first? So the first thing you're going to do is see that these parentheses disappear. So they have distributed, they have used distributive property and got rid of the parentheses. So we're going to put distributive property here, which we talked about some in the last section as well. So make sure you know distributive property, you will use it on and on. All right, so then it says they've combined constraints, we've subtracted, and what are we doing to get to this next step? So they are using subtraction again. All right, so we're using subtraction again. And then we are dividing. So you're going to divide, you want to get S by itself. We want to isolate that variable. So we're going to divide by 0.05. And then you can hit check and you can see that if you're on the right track or not. All right, I'm going to blow this back up. Let's see. Complete the solution by providing the missing information. The jobs would pay the same amount if Eduardo makes how much in sales in a month. Eduardo would earn this much dollars from job A and this much dollars from job B. All right, so let's look above here and see. So what they did was set this expression equal to this expression. They set it up as an equation and they solved, and they got S equals $18,000. So when Eduardo sells $18,000 in whatever merchandise he sells,